If you're looking for a site to start discovering the world of the Internet of Things, IoT, and low-power wide-area networking, then I hope you will find this is a good place. In this totally revised and rewritten course, we will work through all of the basic aspects of the components that comprise a working system and explain the underlying science and engineering. We will select from a huge wealth of devices that have become available over the last few years a popular, low-cost and easy-to-implement connection. We will explain the basics of some of the useful designs and how you can develop your own complete individual system. We will navigate a route through the hardware and software choices and discover how these options may be used to connect devices to devices, machine to machine, and devices to the internet, into the cloud. We are all familiar now with the world of interconnectivity, whether it's for very short-range validation of credit cards or travel tickets, or longer-range connections made to receive television from satellites far above the Earth. In between these extremes are systems such as the TV remote control, Bluetooth and Wi-Fi, and of course the ubiquitous mobile phone. We can plot a graph of the distances over which each of these systems operate and the amount of bandwidth they provide. All may be used to connect IoT devices, but here we're going to concentrate on this area of the graph where very little bandwidth is used over very long distances. The bandwidth down here is low, too low for video use or even to send an audio channel. It's used for applications that need to send short messages, drip-fed over time, similar to very short SMS messages or tiny tweets. This may not be at first sight to be useful, but the messages may grow over time to be important. In this example, the Oxford Flood Management System, sensors have been placed to monitor the local river levels. When connected to the internet and presented on a web page, this trickle of data builds into a very useful facility full of information. This is a first-class example of what can be achieved with a bit of willpower, some knowledge and low-cost sensing devices. Going back to our graph, we can see that we can cover it with TLAs, three-letter acronyms. The graph can be roughly divided into two generic halves, LAN and WAN, local area network and wide area network. Within this area, credit card readers, RFID and say Bluetooth earbuds are connected that run close to your body and so are called PAN, personal area networking. Systems that cover towns or cities are called MAN, metropolitan area networks. And most importantly for this video is this area covered by low power wide area networking, LPWAN. To be fair, there are many systems that can or will operate here. Obviously, mobile phone operators want to provide a service. They can do this from their national network of radio towers and on radio frequencies that they have purchased licenses to use. They therefore charge for their connections, but as yet don't have the 5G technology that offer really low power operation, so we will discount them. There are, however, bands of free, license-exempt radio spectrum, similar to Wi-Fi, and these are used by two competing but incompatible systems, Sigfox and LoRa. Sigfox is a fully commercial operation. It provides true low-power performance, but with patchy coverage, and still costs. LoRa, with LoRaWAN, however, is an alliance of a wide range of suppliers acting in a consortium. There are commercial LoRaWAN suppliers, but more importantly, they use technology that is what is known as open source. The community combines to jointly develop a true, openly agreed global standard for all to use. LoRaWAN developments are coordinated by the LoRa Alliance. National LoRaWAN networks are common in Europe and are slowly being rolled out here in the UK. LoRaWAN does, however, have a massive trump card in its pack. The Dutch are cool, and as if they needed to prove it, in August 2015 covered the whole of Amsterdam with a network of radio transmitters providing free LoRaWAN coverage. It's called the Things Network. It remains a popular project, and because it's also open, has gone viral. At the time of filming, there are over 33,000 active developers